Welcome back, students who are taking Math for Business and Applications, Math for Business and Finance, and Math Applications. We're working on the theory videos for Chapter 22, Business Statistics. And in the last video, we had stopped at price relative. Yep. Okay. So now we're going to pick up with the concept of measures of dispersion. And this is going to be a relatively short video because the following videos are going to end up talking about standard deviation and normal distribution, which gets a lot more complicated. However, before I get started, again, if you don't understand something, watch the video again. These are just concepts. They're not really being applied to anything at the moment. And you have to understand the concept, the underlying concepts, because one gets applied on top of another on top of another. Okay. Now, if you don't understand the concept, watch the videos again, or feel free to telephone and speak with an instructor so that you get it. But as we talk about measures of dispersion here, okay, I'm going back to this underlying concept of frequency distribution. Okay, remember the frequency distribution is how often data exists. Okay, and I'm just going to go and skip back to my original slide here. Okay, so as I was using an example, the previous example, and I realized that you can look at part of the example in the book, but I'm trying to give give you a better feel than just looking at numbers on a page in a textbook. So if I had 1, 2, 3, 2, where's my 2? Okay, get my 2 in there. 2, 3, 4, and 5. Let's just say we have those numbers. And like I said, maybe these are, I don't know, numbers written on a piece of paper, and you have them thrown in a hat. Okay, and so what you're going to do is you're going to pull these numbers out of that hat, and you want to measure the frequencies, okay, and the dispersion, okay. And you'll see what I mean by the measures of dispersion in a moment. So let's say we do this. You pull out the first time you pull out a 0, and then the next time is a 2, next time is a 4, next time is a 4 again, next time is a 5, next time is a 4, next time is a 3, next time is a 2. So that's 1, 2, 3, 4, 5, 6, 7, 8. Let's say the next time you pull out again another 4, and then the last time you pull out a 0. Okay, so the frequency distribution for 0 is 2 times. For 1, it's 0 times. Okay, so remember, this is my frequency distribution. Okay, for 2, it's 2 times. For 3, it's 1. For 4, it's 4 times, and for 5, it's 1. So that's my frequency distribution. Okay, now that frequency distribution, that's all and fine, but we also want to have measures of the distribution, okay? And we can do that in 3 ways with range, standard deviation, and normal distribution. Right? So for range, range is the highest value minus all the way down to the lowest value, okay? So in this case here, our highest the range is from a 5 all the way down to a 0. Okay. Now, granted, we only had these 6 numbers, 0, 1, 2, 3, 4, 5. There's 6 numbers here. We had those numbers in a hat, okay? And we pulled them out 10 times, right? But let's say I had those 5 numbers in a hat, and let's say I only pulled them out 3 times, okay? Let me just theoretically show you this. So let's say we're only pulling them out of the hat 3 times. Let's say the first time we get a 1, the second time we get a 1, and the third time we get a 3. Okay, so for 3 times, my frequency distribution for 0 is once. My distribution for 1 is 2. For 2 is 0. For 3 is 1. For 4 is 0. And for 5 is 0. Okay, that's my frequency distribution. Let me erase that here. That's my frequency distribution. But my range is my highest value, which happens to be a 3, all the way down to my lowest value, which happens to be a 1. Okay, even though there was 6 values in that hat, my range is only 3 to 1, right? The highest to the lowest. Now, to give another example of a range, and remember we're kind of like saying, okay, there's six possible digits in this example, but what if we were talking about something like the a baseball team, and I'm going to just pick I don't know, the New York Yankees maybe, since everybody likes or dislikes the Yankees. All right. Let's say we're talking, we want to talk about, I don't know, the batting averages, okay, of all of the players. Now, I'm making this up. I mean, I don't know the batting averages. Heck, I don't even, if you said, I'd be hard pressed to actually give you a name of somebody on the Yankees because I don't follow baseball, right? But I'm going to just say, let's say there's 30 people on the roster, right? And all 30 people, they have batting averages ranging from 0.000 to whatever the high end is, 0. Let's just say 400. Somebody bats 400. Okay. Well, not everybody's going to have 0. Okay. So maybe on the low end, it's the lowest batting average for one of those people is 30, and not everybody, maybe nobody actually hit 400. Maybe the highest batting average is 380. So my range would be 0.380 and all the way down to 0.100. Okay, so that's the range, the highest value to the lowest value for that particular sample or population. All right. Okay, and so that's one measure of dispersion. Let me get all of this off of here. Okay, and then we have the next measure of dispersion, which I'm not going to cover too in depth right in this particular video because it's probably going to take 2 or 3 videos just for standard deviation. But another measure of dispersion is standard deviation. And what standard deviation does is it says that from a mean, remember a mean is sort of like your average, right? From a mean, the data will fall within a certain percentage range, okay? And for one, and don't quote me exactly on the number here. It's not, I mean, if I want to know what the number is, if I want to know what the percentage is, I'm actually going to go and I can look in a book to find it up, and you'll find it out. But I know generally, and for this purpose, one standard deviation, okay, deviation, one standard deviation is approximately 68%, meaning that if I have a sample or a population, it's going to fall within 68% of the average mean. Okay, so all of the data points that I have will fall within that 68%. That's one standard deviation. Okay, 2 standard deviations falls within, I believe, someplace right around 95%. Okay, so if you have 2 standard deviations, and again, I'm not sure if that number is absolutely correct, and I'm not going to look it up, but for all intents and purposes, knowing that it's 95, it could be 91 for all I know, okay? But the point being is that all of the data falls within, for 2 standard deviations, 95, and I'm going to use that number, falls within the average mean of 95% around the average mean. And then when you get to 3 standard deviations, okay, I believe that's someplace closer to 98%, 98.9 or something like that. Okay, so notice what I'm talking. You get to 100%, you can't get any more, right? But so when we talk about data, generally the most that we're talking about is 3 standard deviations, because that falls within almost 100% of all of that data points would fall within 3 standard deviations of the average mean, or of the mean. Now, realize that we can go to 4 standard deviations, 5, 6. NASA actually deals with, in the realm of 26 standard deviations. Okay, and realize that we can't get to 100. Okay, because 100 means, everything is inclusive. But and you'll see this when you see the graph for normal distribution. Okay, we can talk in terms of 4, 5, 6, 7, 26 standard deviations, but just realize that these are numbers that are coming extremely close to 100%. We're talking thousandths of a percent, close to 100%. And for most of everything within our realm of consciousness, from a normal perspective, everything falls within 3 standard deviations. Yes, like I said, we can use 4 or more, but now you're talking about engineering aspects, medicinal aspects, percentages of how much of a particular drug is, or an element is in a drug, or whatever have you. Like I said, NASA, because they're going to the moon, if they're off by 1/10,000th of a degree, they can miss the entire moon. Okay, or think Mars, right? I mean, how far it is away. So they deal in much, much higher standard deviations. But for the average person, the most we ever end up dealing with is 3 standard deviations. Now, we're going to treat those as a measure of dispersion. And like I said, in the next 2 or 3 videos, I'm going to talk about strictly standard deviation. But when we have a standard deviation, well, actually, I shouldn't have erased all of that. Let me see here. Okay, good. What you're noticing here, let me get rid of this. Get rid of this stuff I actually don't need here. Okay. Another measure of dispersion is what we call normal distribution, and that is covered under what's called like a bell curve. Okay. So out here, all right, this here is called a long tail, and this is called a long tail. Okay, because this is where those 4 and 5 and 6 and 7 standard deviations occur. But we can graph our values, our data points, underneath what's called a normal distribution. And the normal distribution is shaped like a bell curve. Through observation, we know this to be true, and that's, like I said in the first video, that's how statistics came about. And somebody watched this where they were paying attention, mathematicians got involved, and now we have a separate branch because they noticed that most of the data falls within this normal distribution. Now, there is other than normal distributions, and like I said, that's for additional subjects if you were going to study the discipline of business statistics or statistics in general. But you don't need to go to that extreme. Okay, in almost every bachelor's degree curriculum I've ever seen, we only deal with the normal distribution, which looks like a bell curve. Okay, even though some others are given an introductory to abnormal distributions. Right, but after we get them with the standard deviation, we'll actually have another video on the normal distribution. All right, so I had said this was going to be a short video, and it ended up being a little bit longer, but that's just the way it is, because the measures of dispersions, we're going to look at it from three perspectives: the range, standard deviation, and normal deviation. Okay, so if you have any questions, feel free to call, but I will start getting into standard deviation in the next video.